All right, that time of the week right now, a visit from our good friends over at the Imagination Station in downtown Toledo. Sarah Neff has something with her today called the bell jar?
The bell jar, yes.
Due to its shape?
Exactly.
Looks like a bell.
It does.
I'm quick.
You are.
Not really, but go on. You're going to explain how this is going to factor into some science this morning.
I am. Valentine's Day is right around the corner, and we have Scientific Sweetness coming up at Imagination Station. That's February 8th, 9th, and 10th, and all the details for that on our website, imaginationstationtoledo.org. But I did bring one of my favorite activities that you'll see during that weekend, and that is the bell jar.
All right, so explain briefly what this is and what you're going to use it for.
All right, the bell jar actually is a vacuum chamber. So I have a vacuum pump over here, and we're going to use that to draw the pressure out of our chamber.
All right, you guys aren't going to roll me up and vacuum pack me again, are you?
Not again, but it's pretty much the same idea.
Okay, you did that to me before.
But you get to do the
You
vacuuming.
squeezed me like a sardine. All right, what are we going to do today?
All right, so we're going to start out with a balloon.
Okay.
And you know all about atmospheric pressure, right?
Sure.
We have 14.7 pounds per square inch pushing on us all the time. We don't feel it because we're accustomed to it. Same thing goes for our balloon here. So what we're going to do is we're going to actually pop this into our bell jar. All right, and I'm going to go ahead and turn on our vacuum pump. And like I said, we're actually drawing out the extra pressure that is inside our bell jar. So as the pressure decreases, it allows our balloon to grow and get bigger.
The air inside the balloon's contained, so it is expanding as the pressure decreases around it.
Right, right. Okay. All right, so we kind of created a seal on the bottom. So I'm going to go ahead and turn off our pump. You can see that our balloon has expanded and actually filled up the bottom of our jar.
It certainly has.
So I'm going to pull the plug on it, which is going to allow all of the air pressure out here to go rushing back in.
Okay. And it's returned to its normal state or size.
It is. So let's take our balloon out. And as you can see, our balloon is right back to its normal shape. It's elastic, so it went back nice and easy, right?
Okay.
All right, so this balloon represents like one pocket of air. And that's what one pocket of air can do. So I'm going to set this aside, and now we've got some marshmallows. All right, so what if we put our marshmallows in there?
I like the sound of this.
All right, so you can put that whole beaker in there. Now, each one of those marshmallows is a pocket of maybe 100 air molecules, right? And we've got over 1,000 mini marshmallows in this beaker. All right, so I'm going to go ahead and turn this on. And again, we're going to do the same thing where we pull out that air pressure, and that's going to allow our marshmallows to expand. Cool. So we can see, if you look in the side of the jar, you can see where it kind of almost looks like cobblestone. It's pressing up against the side, and those spaces are getting smaller. And we've almost got a popcorn effect coming out of there, right?
Yeah.
So what do you think will happen when we let the air back in here?
I would assume that a marshmallow is pretty elastic. They're chewy. It's probably going to go back to its original size.
All right. So I will turn off our vacuum pump, and I'm going to pull the plug on it again. Let all that air pressure back in. So let's take a look at our marshmallows now.
They actually shrunk a little bit, didn't they?
They did. So if we take a look at them, I've got some that we didn't put in our chamber. We kind of compare them. Like you said, they're kind of wrinkly and smushed. They don't quite look the same as when we started.
Right.
It's because we expanded all of those air pockets so much that we kind of stretched them to their max. So we could pump the air back in and fluff them back up, but that would be a really big process. So I'm just going to get them out of the way. And
we're just about the fun right now.
Right, exactly.
Let's skip that part for now.
And the last thing that we're going to put in is whipped cream. So our balloon was 1 air molecule, our marshmallows were maybe 100 air molecules each, and our whipped cream is like 1,000,000 air molecules.
All right. May I fill up the cup?
You sure can. So you're going to fill that up to the top. And we save the best one for last.
Tasty.
It's a good thing I didn't do that before.
It's legitimate. Okay.
Okay, so what I'm going to do is, we've got this inside the bell jar. We're going to plug this back in, okay? And let's turn on our vacuum pump again. And as you can see, almost instantly, as soon as that pressure starts to draw out, we can see our whipped cream starting to grow. And it's going to grow and grow, and it's actually coming out of the cup. Kind of looks like an ice cream cone, tipped over a little bit.
So this is expanding due to the number of molecules by a greater volume then, correct?
Right. So there are more air molecules in there, so they have more space to grow.
Now, if we let this run for, let's say, 5 minutes, what would happen?
We could actually fill up almost the entire bell jar. Fortunately, we don't have 5 minutes.
That's impressive, though. But I get the idea because that is quickly expanding from a little Dixie cup
Right.
to something that would fill that up completely. I see some pumpkin pie or something right now.
Well, like I said, this is just one of the activities that you'll see during Scientific Sweetness.
All right, and that is the dates of that again?
Are February 8, 9, and 10.
All righty.
And I'm gonna go ahead and turn this off, and I'm gonna let you pull the plug on it this time.
Okay.
So as you can see,
I'm glad you left the lid on.
Like I said, we are expanding those air molecules, kind of stretching them to their max. So now we have nothing but liquid left.
All righty. Well, you guys always are rocking out and having fun over at the Imagination Station. So, Sarah, appreciate you coming in.
Thank you.
Sharing some fun and exciting science with us. It's always a fun part of our Thursday.